this does seem to be working. So I'm going to talk about data.table in R, the port of data.table to PyData in Python. It's quite a technical talk. I might show some code towards the end with OpenMP and C, and I'll talk in detail about benchmarks, how we're benchmarking these different projects, data table in R and Python, Spark, Pandas, and go into detail there. So if you want to look at the homepage for data table, it's r-datatable.com. And then that just redirects to the GitHub page. And so I created this package 12 years ago. And at that time, I was working for Concordia Advisors, an equity market neutral hedge fund. And one of the strategies I was looking after at that time was looking at analyst estimates. And when an analyst changes their recommendation from hold to buy or from sell to hold and changes their EPS recommendation for the next quarter, then ingesting all that data, it's a regular time series data for all cash equities in the world, and then making a signal based on that change and then trading it. So the way it was organized is that each person would research the data for maybe 6 months and then put it into production. So if it failed at night when the Japanese model was trading and the text message I didn't send myself, then it would be my fault for not sending myself a text message to wake myself up and fix the production model. And it was a really great way of working because you were responsible for the ingest of data, the cleaning, and the production, and making sure it worked from end to end. So since then, it's become quite popular. I've released it open source. And as in the introduction, I was really pleased because it started to be used outside of finance, because those same time series aggregations and joins that I was doing for analyst estimates to join to the prevailing observation were being used in genomics, for example. And Arun Srinivasan, who's here today in the audience, he started using it in genomics in his research, in his PhD, outside of finance. And that's really exciting for me. So to explain more about what it actually is, so it's an R package, and the syntax is a little bit like a matrix. So things you do to rows happen in I, things you do to columns happen in J, and then if you do expressions on columns, you can do them by group. And that's it, really. There aren't any verbs, there aren't any chaining at this stage, although you can add an extra square bracket onto the end, which is just standard in base R anyway. So to flesh that out a bit, if you scroll down this home page, we compare base R code on the left to data table code on the right, and it's quite straightforward to read. Select all the rows from the DT column, where the code from the DT table, where the code column is not equal to this string, and select the sum of a different column for those rows and return that value. And then similarly, something so very similar, but grouping by a column just for that subset of rows, calculate the sum of a column and the sum of another column. And then colon equals is like an update in SQL. So it is an update by reference to a subset of columns where the code column is a particular string value and update a column to BNA. Keep on scrolling down, and this is just the manual page for data table, the example section, and it's just one line with a quick string description of what it does. So select the second row. Now, how do you do that in SQL? How do you select the second row in SQL? You can't. There's no syntax in SQL to select the second row. You need to add an extra column which holds the value, which is the second row, and select where the row number is that second row. But SQL, because it's row-based, has no inherent row ordering, and that's very important. That's why people are using R, why they're using pandas in Python, is because we have an inherent row ordering, which is useful for time series. So select the rows 2 and 3. We can pass a vector W into the I clause, so we can have some complicated expression that calculates which rows we want, store them in W, and then pass them back in. So it's for programmatic use in production. I was using it day in, day out, every single minute of the day, and the short syntax becomes very natural very quickly. So keep on going, and we can get some more complicated examples. So for example, towards the end, we can do anything in J, and we can have a curly bracket. I can sometimes have a page of code inside J, which is done by group. Subsets of groups can be accessed with this symbol .sd, and you can do subqueries by group just by using the SD symbol. So here's an example of doing anything in J by group. So we're just using base R syntax. You can use any of the 13,000 packages in R from within this J clause within data table. It'll arrange the groups for you and then call that package on that group of data. So this is a syntax that's been popular in the R world, and we've ported that into Python. So there's this relatively new project, started last year, developed by my colleague Pasha at H2O. So to find that project, it's open source, it's on GitHub, it's in the H2O GitHub repository data table, it's on all the usual Python channels, so you can pip install it. And so it's got the description at the top, the goals. I'll leave you in your own time to go through all the bullet points of the LLVM computations, the fast CSV reading, lazy row indexing and viewing, and the installation. And then I wanted to point out that the documentation is at the very bottom link. So click documentation, and it'll take you to this, this nice page. And scroll down in here, you find common tasks. If you click the first bullet point of common tasks here, then this is the equivalent of what we were seeing on the front page of data table in R. So you can see how it compares. So it tries to mimic the same syntax with I, J, and by. It has the fread and the fwrite. So very similar to data table, you do dt.fread. It has the same underlying C code, so all the advanced parallel jumping of the threads into the middle of the file have you jumped inside a quoted field containing a comma, and that's not a real comma, but it's a comma inside a quoted field. All that kind of logic that works out, have I got a valid jump point, is all shared and parallelized using OpenMP in C. And then the syntax, keep on scrolling down, and you see the similar syntax with I, J, and by. Expressions in I. In Python, you need to prefix column names with an F. So the F dot gives you access to each of the columns. In R, there's lazy evaluation, so there's a lot of substitute on the R expressions to convert them to use the column names as if they are variables. And then there's some nice, more complicated examples here, and so on. So as I said, it's all open source. It's available right now, and it's a GitHub project, so feel free to raise issues, make feature requests, and make comments directly in these GitHub projects. So now just to compare this space, so in terms of benchmarks. So on the data table homepage, there's this image, which is deliberately small so that when you click it, it takes you to the benchmark page. So there's quite a lot of detail I'm going to go through on this. So 4 years ago, 2014, I made these particular grouping benchmarks, and there was a great blog post by Matthew Rocklin on the DAS project. He did a blog post about honesty of benchmarking, which was excellent. One of the things he pointed out was that you shouldn't create a benchmark and then stand up at a conference and say how great it is, because you've had the benefit of tuning your code to pass your benchmarks just before the conference, and it looks great, but then that's unfair because the other projects haven't managed to have the benefit of your fantastic benchmark. So this is passing Matthew Rocklin's test, because I haven't changed any of these benchmarks for 4 years, and they were published at the time. Those groups knew about them, and we're just updating these benchmarks literally without any other changes at all yet. So the first thing is there's 3 tabs here: 0.5 gig, 5 gig, and 50 gig. So you should select the size of data that you have. So if you have 20 terabytes of data, then this benchmark isn't going to help you, because we're not benchmarking massive databases with multiple terabytes yet. We are going for a single node, what you can do on a single node so far. 50 gig is kind of what most people ask us about, or less. 50 gig is still quite big, really, for most people. We can do 500 gig, half a terabyte on this machine. We have one machine that we run all these benchmarks on, and we have these systems at the moment. So we're testing Dask, Datatable, dplyr, Julia, Pandas, PyDatatable, and Spark. And all these software are allowed to benefit from any of the hardware on our box. So we have 2 GPU cards, we have a terabyte NVMe, we have 20 CPUs, and 2 10 terabyte HD disks. So we're going to intend to increase the data size as much as we can do on this one machine. And if one software can go multi-threaded, then it should be allowed to, and you should be able to compare that to another software which uses GPU, because that's the choice that you face as users. So we're looking at the 0.5 gig data size here at the moment, and we have 5 questions, or 5 tests. So the second thing I wanted to point out is that we don't just put the timing, but we put the syntax as well, so that you can compare the syntax and so that you know what the test is doing. So the first test is grouping one column by another column, and that's it. And the result is 100 rows by 2 columns, and it's an easy one. It's lots of small groups. And there's a big difference. We can see straight away that Julia is quite slow on this, and Datatable, PyDatatable are very fast, and faster than Spark on a single node. Of course, on Spark, that can scale to multiple nodes, but perhaps if your data fits on a single node, you don't need that ability to go multi-node. The next thing to notice, there's 2 bars. The first thick bar is the first run, and the second thinner bar is the second run. And that's it. We just do 2 runs, because to run the entire benchmark takes 14 hours for all these systems. So every time you see a beautiful violin plot on Stack Overflow or on a blog post, doing 100 runs of each choice, comparing the mean and standard deviation of 5 different choices, and it's 100 runs, I just cry myself to sleep, Because if you have enough time to wait for 100 runs of the thing that you're benchmarking, then you are doing it wrong. We only want to speed up things that take an hour. So we want to take an hour down to a minute. And to be able to test that, you have to run it for an hour, because the data has to be so big that it has to squash all those cache lines into those caches, and it has to be big enough to stress that machine. So we don't run Chrome on this box. We don't run Slack on this box. Each system runs by itself in a one-at-a-time fashion. And at the top is the total time for the 5 tests. So, this is another thing to point out is that we chop. So it's a standard linear scale axis so that we can compare the fastest solutions, Datatable, PyDatatable, and Spark. And then the other systems are so much slower that we just chop at about 20% above Spark. Another really important point is that this is updated every day. So we haven't produced a blog article with these benchmarks, which becomes stale and then gets requoted and linked to in 6 months' time and it's wrong. It's live. So every day we run it, and every day we fetch the latest dev version of each software. So it's a service to developers, ourselves included, as well as a service to users. So we have 5 different tests, some easy ones and some harder ones. And then we do 2 runs of each test, and then we sum it up at the top, and we compare the total times as well. So this is just grouping. We've started with grouping first. The great thing is there hasn't been any complaints about it so far, so no other teams have said they didn't know about it or that it's wrong or unfair. We've been raising GitHub issues with the other projects, and we really feel as if we're working together with other teams to learn from each other and to improve it and to work towards the fastest we can do. It has 125 gig RAM on this box. So that's fair, I think, because when you go up to 50 gig, you find that Pandas doesn't work and Dask doesn't work because the file can't be read on this machine, which has 125 gig of RAM. So now you know that you've got some sense of where these systems start to fail, let alone being slow. And so we don't intend to increase the RAM on this machine because then everything just starts to work. But you know now how much RAM you need to buy to make it work. So that's all I had on the benchmarks. I think do I have 4 minutes? So just to very quickly show the code that we're doing in PyDatatable and R Datatable is in C, C++, and OpenMP. So just to give you a flavor of that, I thought I'd quickly scroll through what I worked on recently, which is sorting. And this is, so C code. Let's see how many lines it is. It's 1,000 lines, so it's come down from a few months ago where it's 1,500 lines. And towards the end, let's see what we have. We have a pragma. So it's an OpenMP parallel loop. The number of threads is set by you, so you can limit it. It just uses all the cores by default, but you can limit it if you want. And little things like accounting sort using unsigned int 16 so that the counts fit inside cache. So making the variables as small as possible so that the threads are cache efficient as they go in parallel. and then looping through in parallel through the groups you have so far. It builds a key of the columns. So if you have 3 columns, it builds a condensed, compressed key first, and then does a forwards radix in parallel on that. And I don't know, have we got many C programmers in the room? Oh, lots of you. So I can go through this afterwards if anybody's interested. So this is what I spend my life doing, messing around with C code. And it's great to have the benchmarks now so that we can continue and to continue improve as much as we can. Thank you. Yeah. So the first question, I always love this one. This is always first. What are advantages from data table compared to dplyr, especially when you think of code readability? I'm so glad you asked, because I even have it linked on the front page here. Oh, no, I don't. It's here. If you want to ask the one about pandas merges in Python, why they're faster, I've got that one bookmarked as well. You can ask me that one. So DT versus dplyr. So this has 86,000 views on Stack Overflow, and this answers the question far better than I can do. And this is by Arun, who's in the room. And let's scroll down. So he's got the winning answer at the moment of 408 votes with plus 200 votes, and that wasn't me, by the way. So it goes through speed. I don't like that people say that you should use data table for speed, because when the other packages do catch up, and they will catch up, then nobody will think there's any reason to use data table, will they? And it's really true that it's not really speed, it's the syntax, and it's the brevity, because I'm using it day in, day out, every 5 minutes of the day. And this goes through, it's also memory usage, of course, not just speed. But then it goes on and has some syntax differences. And this is the section that answers this question in most detail. So it compares the consistency of the syntax, because we feel that data table is consistent. You can do anything in J by, and that's it. So there's no, you don't need, summarize does things by one row at a time, whereas we can do that, or we can do a plot, or we can do something else, and whatever you throw into J, it just does the right thing. And so it's a consistency contemporaneously across the different queries that you're doing in the data table, but it's also consistency over time, because we haven't changed the syntax because there's something inherently right about it, I feel. And so there's the full answer on Stack Overflow. When is there going to be a Python Windows wheel on PyPy with pre-built x86 binaries? I think Pasha and the others are working on that. And if you speak up and make a noise about it, then it'll be done quicker. We work on the basis of feedback from the community. So please raise the issue, please +1 it, please email Shri, email sales, and if you want to give us some cash, then that'll help too. When is there going to be why do you use .sd for subset? What does it stand for? Thank you for that one, Martin, because that's another one that's common on Stack Overflow. It stands for subset of data, and it's just a symbol which means subset of data, so that you can use it in J. And so for example, if you're grouping and you want the rows from the group which are greater than 2 standard deviations of the variance within the group, then you can do .sd, open square bracket, and the I clause in the SD gets applied by group. Yes, will you add rapids in your benchmarks? Yes, that'll be added. We do have 2 GPU cards on this box, so we'll add that, and we'll also add mapd. I don't know how long it'll take, because we just have Jan Gurecki, who's done all these benchmarks, by the way, which are great. He's half-time for H2O while he's working on his master's. So it depends on how much people time we can get to do that. I think that's all the questions.
Okay. Perfect. Thank you very much.